Okay, now we're going to talk about the chain rule. Chain rule happens when there are functions nestled in with other functions. Think about the Russian stacking dolls. If you don't know what those are, you can find a YouTube video about Russian stacking dolls. It's kind of like that. You've got this outer function saying that this function is squared. That's like saying something is squared, right? Well, instead of x, there's a bunch of other stuff. So the outer function is the squared part. The inner function is the stuff. So what I used to say to students is it would be, think about it this way. The outer part is squared. Right? And then you've got this stuff. Well, to take the derivative of that, you take the derivative of the outer, which is 2 times that stuff, but then you take the derivative of the stuff. So that's what we're going to be doing here. And I don't know if the stuff is helpful or not, but our derivative of f is 2 times all of that stuff, and then 2 subtract 1 to the first power. The derivative of g, of the stuff, is 12x cubed minus 5. So when we do the chain rule, so this was just an example. When we do the chain rule on the example, we would have 2 times that function, their first power, and then you keep the stuff untouched. Now you multiply by the derivative of the stuff. And then these outer things can be multiplied together. And because there are no larger exponents on the outside, you could actually simplify this. But I'm going to go ahead and stop this now, and we're going to get started on an actual example. So I'm going to erase all of this stuff. Okay, so this outer function is something squared. So the derivative will be that something squared. So 2 times that something, the first power. Now we're going to multiply it by the derivative of that something. Well, there's the something. The derivative of that is just 8x. And then we make sure we bring down that inside function. To simplify, we're going to multiply the outside parts together. So because the only exponent is the power of 1, we can go ahead and distribute. For this one, we're going to distribute to simplify. If that would have been to the third power, then I would have just said leave your answer as it is. That's simplified enough. So we have 64x cubed plus 48x. So that would be the derivative of this chain rule. So now we've got 2 things going on. We've got this outer function. So the f derivative is 2 times all that stuff to the first power. But then inside here, we've got another chain rule. So this whole thing is g. So the derivative of g, well, now the derivative of this parentheses to the fourth is 4 parentheses to the third, and then the derivative of 4 is 0. So Here's the derivative of f, here's the derivative of g, and then this inner function is h, and that derivative is 4x cubed. Okay, so dy dx says we're going to take the derivative of the f function, so 2 parentheses to the first power. Now we're going to multiply that by the derivative of the g function, and we're going to multiply that by the derivative of the h function. So everything that's on the outside, we're going to simplify, and we're going to bring down all those inside functions. Oops. Inside that is the whole thing. Sorry about that. And this is, there you go. So we have 8x cubed times x to the fourth minus 5 to the fourth power minus 4 times let's see what we have. We could have actually multiplied this out front. So I'm just going to cross that off, and I'm going to put 32 right there. Because this has an exponent of 4 and this has an exponent of 3, I'm going to go ahead and let you leave it just like that. All right, we already did an example, so this is still the chain rule. But the problem is it's the chain rule and the product rule. So this entire thing is the f of x, and this is g of x. This is going to be confusing because for the product rule, this is f and this is g. And the product rule derivative is f times g prime plus g times f prime. But the chain rule says this outer thing, maybe. So now we're going to suspend what we know about this and this. Let's ignore that. Now we've got this chain rule thing. So the derivative of f, use the chain rule. So it's 5 stuff to the fourth power times the derivative of that inside stuff. So that's this f of x, this is that's derivative. G of x, that derivative is just 9x squared. And we're going to plug it into this right there. So it's f times the derivative of g plus g times the derivative of f. And then over here, this 5, this 12x cubed can come out front. Those two things could probably, oh, and this 5 right there. So, and that 5 right there, because that's not part of the cubic. Oh, no, I already did the 5. Okay, good. We'll leave that as it is. then these things can be simplified further. So 180 x to the 6th minus 60 x cubed Okay, this other part over here, we can just do that double distributive. Nine x squared times 3x to the 4th is 27x to the 6th. Plus 9x squared times 4 is 36 squared. And I think that's as simplified as we're going to get it. Okay, you're going to do something similar like that with the quotient rule. But here's the tricky part. There's a quotient rule on the inside of a chain rule first. So if we took dy dx, it would be 4 times that to the 3rd. Now we have to multiply this by the derivative of all of that. Well, all of that is the quotient rule. It's g times the derivative of f subtract f times the derivative of g all over g squared. And then notice you've got this and this, so that's going to be cubed because they're the exact same thing. This to the first power times this to the second power. So this whole thing is cubed. And then inside there, I'm not going to take the time to do all of that, but you'd simplify inside here. And over here, you do the distributive. So maybe I will do it. So on this part right here, we're going to have 16x cubed plus 12 times this stuff. So up here, we have negative 24x to the 6th minus 60x squared. And now we're going to subtract whatever's inside here. So we have a negative 32x to the 6th minus 24x cubed. And then you just keep simplifying that if you can. These can be multiplied further. This subtract a negative, both of those become add a positive. $16x. Yeah, so I'm going to let you guys finish up doing the math. I did not make it easy on myself, and I'm not going to take the time in the video to multiply that out. But at the very end, once you do this distributive, any of the terms that can be added together, you would go ahead and do that. Okay, decided to go ahead and multiply it out just to not leave you hanging. And then notice when I multiplied those two binomials, I ended up with this negative 288x to the 6th. Well, that can be combined, and those are the only two things that can be combined So then the final derivative of that very annoying chain rule should be simplified to that. Again, you might have a professor that says, no, I want the denominator, I want that expanded. So whether you use Pascal's triangle rule, the binomial expansion rule, or just simply the old-fashioned way, multiply those two first, then multiply it by the third time, however you find it best. All right, that's it for chain rule.